Synopsis, the Enterprise Governance Brain. IGA 2026 and NeuroGov Plus, Advanced AI. This white paper introduces IGA 2026, Intelligent Governance Architecture 2026, and NeuroGov Plus, Advanced AI, as a new approach to enterprise intelligence where governance becomes an integral part of AI architecture rather than an external control mechanism. Core premise. Most AI systems are designed to learn, predict, recommend, automate. However, enterprises also require accountability, governance, compliance, explainability, auditability, assurance. The paper argues that intelligence alone is insufficient for enterprise decision-making and proposes that governance must be embedded directly within AI systems. IGA 2026 Framework. IGA 2026 is presented as a governance framework that defines governance principles, governance controls, governance operating layers, governance assurance mechanisms, governance decision models. It acts as the constitutional layer for governed enterprise intelligence. NeuroGov Plus, Advanced AI. NeuroGov Plus operationalizes IGA 2026 and functions as the enterprise governance brain. Its purpose extends beyond traditional AI by combining intelligence generation, governance reasoning, policy evaluation, decision authority, assurance mechanisms. The objective is not merely to think, but to govern. Inform rightward arrow govern rightward arrow assure model. The architecture is organized into three layers. Inform transforms data into intelligence through domain GPT intelligence, AI memory, AI trained memory, query intelligence, replay intelligence. Govern transforms intelligence into governed decisions through Analyzer 1.0, Policy Engine, Decision Authority, Possible Governance Outcomes, Allow, Condition, Hold, Block, Assure, provides governance proof through audit evidence, traceability, compliance verification, governance replay, decision explainability. This model forms the foundation of governed enterprise intelligence. Runtime governance architecture. Own data. Downward arrow. Runtime calculation. Downward arrow. KPI engine. Downward arrow. TSI engine. Downward arrow. OSI engine. Downward arrow. RMSE engine. Downward arrow. GPT intelligence. Downward arrow. Analyzer 1.0. Downward arrow. Policy engine. Downward arrow. Decision authority. Downward arrow. Assure. This ensures governance decisions are derived from live enterprise data rather than static reports. Governance metrics. 4 governance-oriented indicators are introduced. Metric purpose. KPI enterprise performance. TSI Trust Stability Index. OSI Operational Stability Index. RMSE Predictive Reliability and Confidence. Together they provide a multidimensional assessment of organizational health. AI memory and AI trained memory. AI memory maintains runtime context and governance observations. AI trained memory stores historical outcomes, governance patterns, institutional knowledge, organizational learning. These capabilities enable continuity, learning, and replay intelligence. 1 Governance brain rightward arrow N enterprise domains rightward arrow N GPTs. A central architectural principle is reuse. 1 governance brain can support multiple domain-specific GPTs such as Finance GPT, HR GPT, Healthcare GPT, Pharma GPT, ESG GPT, Logistics GPT, Manufacturing GPT, Education GPT, Smart City GPT. Governance remains common while domain intelligence varies. Management and Board Advisory. The architecture ultimately supports decision-makers through Management Advisory, Operational Recommendations, Board Advisory, Strategic Governance Recommendations. This links enterprise intelligence directly to governance oversight. Key strategic hypothesis. The white paper proposes that governance must move from an external review activity to an embedded architectural capability. This leads to IGA 2026. Downward arrow. NeuroGov Plus. Downward arrow. Enterprise Governance Brain. Downward arrow. Inform rightward arrow. Govern rightward arrow. Assure. Downward arrow. One Governance Brain. Downward arrow. N Enterprise Domains. Downward arrow. N GPTs. Power Summary. The Enterprise Governance Brain is proposed as a new category of enterprise software that combines intelligence, governance, decision control, assurance within a single architecture. Rather than asking only what happened, it seeks to answer, should the organization proceed? The vision is summarized by two strategic statements. AI thinks rightward arrow. Governance decides rightward arrow. Assure proves. One Governance Brain. Rightward arrow. N Enterprise Domains. Rightward arrow. N GPTs. These statements represent the foundational philosophy of IGA 2026 and NeuroGov Plus, Advanced AI, positioning governance as a first-class architectural capability in future enterprise intelligence systems. IGA 2026 and NeuroGov Plus, Advanced AI. The Enterprise Governance Brain. Discussion White Paper, version 1.0. Author: Dr. Pradeep K. Suri. Inventor and architect. NeuroGov Plus, Advanced AI, Analyzer 1.0. Strategic statements. AI thinks rightward arrow. Governance decides rightward arrow. Assure proves. One Governance Brain. Rightward arrow. N Enterprise Domains. Rightward arrow. N GPTs. https://sites.google.com/view/ngpt neurogov/home. Executive Summary. Artificial intelligence has transformed how organizations process information, predict outcomes, and automate operations. However, most AI systems remain intelligence-centric rather than governance-centric. They can recommend actions but often lack mechanisms to ensure accountability, explainability, policy compliance, auditability, and decision assurance. This white paper introduces IGA 2026, Intelligent Governance Architecture 2026, and NeuroGov Plus, Advanced AI, a proposed framework and operating architecture designed to create governed enterprise intelligence. Within this model, NeuroGov Plus functions as an enterprise governance brain that transforms enterprise data into governed, explainable, auditable, and assured decisions. The governance gap in artificial intelligence. Current AI systems excel at pattern recognition, prediction, recommendation, automation. However, enterprises continue to struggle with decision accountability, governance oversight, regulatory compliance, audit readiness, explainability, evidence-based assurance. The result is an intelligence governance gap. The key question becomes: can intelligence operate without governance? IGA 2026 proposes that governance must become an embedded architectural component rather than an external review process. IGA 2026, Intelligent Governance Architecture 2026. IGA 2026 is proposed as a governance framework for enterprise intelligence systems. Its purpose is to define governance principles, governance controls, governance operating layers, governance assurance mechanisms, governance decision models, IGA 2026 serves as the constitutional layer of enterprise governance. It does not replace existing systems. Instead, it provides a governance structure through which intelligent systems can operate. NeuroGov Plus, Advanced AI. NeuroGov Plus is the operational realization of IGA 2026. It functions as the enterprise governance brain. The governance brain concept extends beyond traditional AI by integrating intelligence generation, governance reasoning, policy evaluation, decision authority, assurance mechanisms. The objective is not merely to think, but to govern. Enterprise governance brain concept. Traditional AI systems perform four primary functions: learn, predict, recommend, automate. The governance brain introduces additional functions: govern, control, assure, explain, authorize. This creates a new category of enterprise systems: governed enterprise intelligence. Architecture overview. Governance hierarchy. IGA 2026. Downward arrow. NeuroGov Plus, Advanced AI. Downward arrow. Inform, govern, assure. Downward arrow. Analyzer 1.0. Policy engine. Decision authority. Downward arrow. Domain GPTs. Downward arrow. Runtime cockpits. This hierarchy separates governance doctrine from governance execution. Inform layer. The inform layer transforms enterprise data into intelligence. Key components include domain GPT intelligence, AI memory, AI trained memory, query intelligence, replay intelligence. Its objective is to provide contextual and explainable enterprise intelligence. Govern layer. The govern layer transforms intelligence into governed recommendations. Core components. Analyzer 1.0. Evaluates risk, exposure, compliance, readiness, governance health. Policy engine. Applies corporate policies, regulations, standards, governance rules. Decision authority. Determines, allow, condition, hold, block. Assure layer. Assure provides governance proof. Capabilities include audit evidence, traceability, compliance verification, governance replay, decision explainability. The purpose of Assure is to demonstrate why decisions were made and whether they complied with governance requirements. Runtime governance architecture. NeuroGov Plus operates using runtime intelligence. Own data. Downward arrow. Runtime calculation. Downward arrow. KPI engine. Downward arrow. TSI engine. Downward arrow. OSI engine. Downward arrow. RMSE engine. Downward arrow. GPT intelligence. Downward arrow. Analyzer 1.0. Downward arrow. Policy engine. Downward arrow. Decision authority. Downward arrow. Assure. This architecture ensures that governance decisions are generated from live enterprise data. Governance metrics. The framework introduces four governance-oriented indicators. KPI. Enterprise Performance Measurement. TSI. Trust Stability Index. OSI. Operational Stability Index. RMSE. Predictive Reliability and Confidence Measurement. Together these indicators provide a multidimensional view of organizational health. AI memory and AI trained memory. AI memory maintains runtime context and governance observations. AI trained memory stores learned governance patterns, historical outcomes, and institutional knowledge. The combination enables organizational learning. 1. Governance brain rightward arrow N enterprise domains rightward arrow N GPTs. A central principle of NeuroGov Plus is architecture reuse. A single governance brain can support Finance GPT, HR GPT, Healthcare GPT, Pharma GPT, ESG GPT, Logistics GPT, Manufacturing GPT, Education GPT, Smart City GPT. Each domain inherits governance capabilities while maintaining domain-specific intelligence. Management and board advisory. Governance intelligence ultimately supports decision makers. Outputs include management advisory, operational recommendations, board advisory, strategic governance recommendations. This creates a direct link between enterprise intelligence and governance oversight. Discussion questions. The following questions are proposed for expert review. 1. Should governance be embedded inside AI architectures? 2. Can a governance brain become a new enterprise software category? 3. Is inform rightward arrow govern rightward arrow assure a viable operating model? 4. Should decision authority remain separate from intelligence generation? 5. How should governance assurance be measured? 6. Can one governance brain support multiple enterprise domains? 7. What role should AI memory play in governance systems? 8. How should governance evidence be standardized? Replay intelligence, expert review questions and proposed answers. These questions are fundamental to validating the IGA 2026 and NeuroGov Plus, Advanced AI, vision. 1. Should governance be embedded inside AI architectures? Proposed answer, yes. Reasoning. AI can generate intelligence but cannot guarantee governance. Governance added after decisions is reactive. Governance embedded inside architecture is proactive. Risk, compliance, policy, and assurance become part of decision-making. Enterprise decisions require explainability and accountability. Conclusion. Governance should be a native architectural component rather than an external review process. 2. Can a governance brain become a new enterprise software category? Proposed answer, yes. Reasoning. Current enterprise categories include ERP, CRM, SCM, BI, AI platforms. None focus on governance-centered intelligence. The governance brain introduces intelligence, governance, assurance, decision control within a single architecture. Conclusion. The enterprise governance brain has the potential to become a new enterprise software category. 3. Is inform rightward arrow govern rightward arrow assure a viable operating model? Proposed answer, yes. Reasoning. Every enterprise decision follows a similar pattern. Inform. Understand facts. Govern. Evaluate policies and risks. Assure. Validate compliance and evidence. This mirrors real-world governance workflows. Conclusion. Inform rightward arrow govern rightward arrow assure is a practical and scalable operating model. 4. Should decision authority remain separate from intelligence generation? Proposed answer, yes. Reasoning. Intelligence and decision-making serve different purposes. Intelligence layer provides insights, predictions, recommendations. Decision authority layer provides governance control, accountability, final authorization. Keeping them separate reduces bias and improves governance. Conclusion. Decision authority should remain independent from intelligence generation. 5. How should governance assurance be measured? Proposed answer. Through measurable governance indicators. Suggested metrics. Compliance score. Policy adherence. Traceability score. Decision lineage visibility. Evidence completeness. Availability of supporting evidence. Audit readiness. Ability to withstand audit review. Governance health. Overall governance effectiveness. Conclusion. Governance assurance should be measured using objective, auditable metrics rather than subjective opinions. 6. Can one governance brain support multiple enterprise domains? Proposed answer, yes. Reasoning. Governance principles are largely universal. Common elements. Risk. Compliance. Policies. Controls. Assurance. Domain-specific intelligence changes, but governance foundations remain similar. Example. One governance brain can support Finance GPT, HR GPT, Healthcare GPT, Pharma GPT, ESG GPT, Logistics GPT, Manufacturing GPT, Education GPT, Smart City GPT. Conclusion. One governance brain can support multiple enterprise domains through a shared governance core and domain-specific intelligence layers. 7. What role should AI memory play in governance systems? Proposed answer. AI memory should act as the institutional memory of the enterprise. Functions. Context retention. Remember governance context. Historical decisions. Store decision history. Governance patterns. Identify recurring risks and outcomes. Organizational learning. Support continuous improvement. Replay intelligence. Enable decision replay and audit review. Conclusion. AI memory should preserve organizational knowledge and governance continuity. 8. How should governance evidence be standardized? Proposed answer. Through a structured governance evidence framework. Evidence categories. Data evidence. Transactions, records, KPIs. Document evidence. Policies, SOPs, regulations. Media evidence. Images, videos, recordings. Decision evidence. Governance decisions and approvals. Audit evidence. Audit trails and logs. Standard components. Each evidence item should include Evidence ID, Source, Timestamp, Decision Reference, Policy Reference, Owner, Retention Period. Conclusion. Governance evidence should be standardized using a common evidence model to ensure consistency, traceability, auditability, and assurance. Power summary. These 8 questions collectively validate the core hypothesis of IGA 2026 and NeuroGov+. Governance must move from an external review activity to an embedded architectural capability. This leads to IGA 2026. Downward arrow. NeuroGov+. Downward arrow. Enterprise governance brain. Downward arrow. Inform. Govern. Assure. Downward arrow. One governance brain. Downward arrow. And enterprise domains. Downward arrow. And GPTs. Strategic outcome. AI thinks rightward arrow governance decides rightward arrow assure proves. One governance brain rightward arrow and enterprise domains rightward arrow and GPTs. 15 Preliminary conclusion. IGA 2026 and NeuroGov+ propose a shift from intelligence-centric systems toward governance-centric systems. The proposed enterprise governance brain combines intelligence, governance, assurance within a single architecture. The framework is summarized as AI thinks, downward arrow, governance decides, downward arrow, assure proves, and one governance brain, downward arrow, and enterprise domains, downward arrow, and GPTs. This white paper is intended as a discussion document for enterprise leaders, governance professionals, technology architects, auditors, regulators, and academic researchers interested in the future of governed enterprise intelligence. Power Summary. NeuroGov Plus, Advanced AI, Enterprise Governance Brain Roadmap. This image represents the complete evolution path of IGA 2026 and NeuroGov Plus, Advanced AI, from a governance vision to enterprise-wide adoption. It is not merely a technology roadmap. It is a governed enterprise intelligence life cycle. One vision. Everything starts with a vision. The vision defines why governance is required, why AI alone is not enough, why intelligence must be governed, why organizations need assurance before execution. The strategic vision is: AI thinks rightward arrow, governance decides rightward arrow, assure proves. 2 IGA 2026 framework. The vision is converted into a formal governance framework. IGA 2026 provides governance principles, governance standards, governance controls, governance assurance, governance maturity models. IGA 2026 becomes the constitutional layer of the architecture. 3 NeuroGov Plus architecture. The framework is operationalized through NeuroGov Plus. NeuroGov Plus acts as the execution architecture for governed intelligence. It converts governance theory into enterprise reality. 4 Enterprise Governance Brain. At the center of the architecture sits the enterprise governance brain. The governance brain performs 1 Reasoning, 2 Learning, 3 Governance, 4 Decision support, 5 Assurance. It becomes the central intelligence layer of the enterprise. 5 Inform, Govern, Assure. The governance brain operates through 3 foundational layers. Inform. Creates intelligence. Provides data understanding. Context. Query intelligence. Replay intelligence. Govern. Applies governance. Provides policy evaluation. Governance reasoning. Risk assessment. Decision control. Assure. Provides proof. Provides auditability. Traceability. Compliance. Evidence. Together these 3 layers create a governed intelligence ecosystem. 6 Governance control layer. The image shows 3 key governance engines. Analyzer 1.0. Analyzes risk, exposure, compliance, readiness, performance. Policy engine. Applies policies, standards, SOPs, regulations. Decision authority. Produces final governance outcomes. Possible decisions. Allow, condition, hold, block. This is where intelligence becomes governance. 7 Runtime governance engines. Governance must operate in real time. The runtime governance layer introduces KPI. Measures performance. TSI. Measures trust stability. OSI. Measures operational stability. RMSE. Measures predictive confidence and quality. Together these metrics create governance health intelligence. 8 Domain GPT layer. After governance is established, the architecture expands into domains. Examples: Finance GPT, HR GPT, Pharma GPT, Healthcare GPT, ESG GPT, Logistics GPT, Manufacturing GPT, Education GPT, Smart City GPT. All GPTs inherit the same governance brain. This is the meaning of 1 Governance brain rightward arrow N Enterprise domains rightward arrow N GPTs. 9 Testing. Testing validates functionality, governance controls, performance, security, accuracy. The image correctly places testing after architecture. This reflects enterprise engineering discipline. 10 Validation. Validation answers Does the system actually work? Validation includes business validation, governance validation, compliance validation, user validation. 11. Enterprise adoption. Only after validation does enterprise rollout occur. Enterprise adoption includes deployment, training, governance enablement, change management, continuous improvement. This is where value is realized. Architectural message of the image. The image communicates one powerful idea. Vision. Downward arrow. Governance framework. Downward arrow. Architecture. Downward arrow. Governance brain. Downward arrow. Governance layers. Downward arrow. Governance engines. Downward arrow. Domain GPTs. Downward arrow. Testing. Downward arrow. Validation. Downward arrow. Enterprise adoption. Power conclusion. This image establishes that NeuroGov Plus is not a GPT, not a dashboard, and not a standalone AI application. It is a governance operating architecture implemented through IGA 2026 and operationalized through NeuroGov Plus, Advanced AI, to create the enterprise governance brain that supports 1. Governance brain rightward arrow N enterprise domains rightward arrow N GPTs. With the ultimate objective. AI thinks rightward arrow governance decides rightward arrow assure proves. This image is effectively the master roadmap of the entire NeuroGov Plus and IGA 2026 vision. About Dr. Pradeep K. Suri. Dr. Pradeep K. Suri is an enterprise technology architect, governance thinker, author, and innovator with more than 5 decades of experience spanning software engineering, enterprise systems, manufacturing, healthcare, ERP integration, cloud computing, governance frameworks, and advanced artificial intelligence architectures. Throughout his career, Dr. Suri has worked across diverse industries including manufacturing, textiles, healthcare, logistics, production planning, enterprise resource planning, and large-scale business transformation initiatives. His professional journey has included work with organizations in India, the United States, and Southeast Asia, contributing to enterprise solutions involving Oracle, SAP, custom software platforms, and cloud-enabled systems. His work has progressively evolved from traditional enterprise applications toward the design of governance-centric intelligent systems. This evolution led to the development of several original concepts and frameworks focused on creating accountable, explainable, and auditable enterprise intelligence.